let V be a vector space with dimension of V is equal to n. That means a finite dimensional vector space with dimension of V equal to n over a field F. Over a field F. Then V is isomorphic to Fn, where Fn is defined as Fn is F cross so on taken n times. Okay, so let's directly start the proof. So since we are given that V has dimension equal to n, so it's a finite dimensional vector space over F. So we can choose a basis with cardinality n. So let V1, V2, and Vn be the basis of V over F. Then for any V belonging to F, belonging to V, we can write this V is equal to alpha 1 V1 plus alpha 2 V2 plus so on plus alpha n Vn. Okay. So now we define a linear transformation. Now we define a mapping between vector space V and this Fn. Now define pi from V into Fn by pi of V is equal to alpha 1, alpha 2, alpha n. So that means these coefficients that we have used from that we have taken from the field F to express this V as a linear combination of these basis vectors. Then we define this mapping phi of V to be an n tuple where the coordinates are the coefficients of VI's. Then we will show that this mapping is a linear mapping and it is also a bijection. So now we show pi is linear and a bijection. Okay. So now let's choose some two elements. Let V is equal to summation I from 1 to n alpha I Vi, and suppose U is equal to summation I from 1 to n beta I Vi. Be any two elements, be any two, not actually elements, we shall use the term vectors. Be any two vectors in V. And let C be any scalar from F. Then we have to show that T of, then phi of CV plus U is equal to C phi of V plus phi of U. तो ये चीज हमें दिखाना होगा फिर. तो मैं इस तरह से हम इस तरह से करेंगे. Phi of CV plus U. We will show this is equal to C phi of V plus phi of U. ठीक है. Now first let's compute what is the CV plus U. So now then CV plus U, this equals C, then summation I from 1 to n alpha I Vi, then plus summation I from 1 to n beta I Vi. Then this can be written as this actually equals summation I running from 1 to n, then we can at once write C alpha I plus beta I into Vi. ठीक है. So thus T this pi of, so thus pi of CV plus U. Now this equal to pi of, now let's expand it. So first this is equal summation I from 1 to n C alpha I plus beta I Vi. तो इसको अगर हम expand करेंगे this equal to pi of, now the first term is C alpha 1 plus beta 1 then V1, then the second term is C alpha 2 plus beta 2 then V2, then plus so on. The last term is C alpha n plus beta n into Vn. Now by definition of this pi maps this vector into an n tuple, which is obtained by just taking the nth coordinate as the ith coordinate as the ith coefficient of Vi. Coefficient of Vi यहाँ पे हमें लिखना है, this is how we define this mapping phi. So the first coordinate is equal to C alpha 1 plus beta 1. Then the second coordinate is C alpha 2 plus beta 2 and so on C alpha n plus beta n. तो इस तरह से अब हमने मैपिंग phi को डिफाइन किया है. It is an n tuple, image of any vector is an n tuple whose ith coordinate is the image of Vi. Sorry, not the image but the coefficient of Vi in this representation of CV plus U as a linear combination of the basis vectors with some scalars. Now, using the properties of this coordinate vector, this coordinate vector can be written in this way. We can write this is equal to C alpha 1, then second term is C alpha 2, and so on, C alpha n, then plus beta 1, beta 2, beta n. Now this equals C alpha 1, alpha 2, alpha n plus beta 1, beta 2, beta n. Now again by definition, we can write C here, and this is the representation, this is the coordinate vector of V. These are the coefficients of in the representation of V. वो कहाँ पे हमने लिखा था? So it is here, alpha 1, alpha 2, alpha n, they are the coefficients of Vi's in the representation of V in the ordered in this basis. And similarly, beta 1, beta 2, beta 2, beta n, they are the coefficients of Vi's in the representation of U with this basis of V. So therefore, this first n tuple, this is pi of V, and the second n tuple is pi of U. So therefore, we have shown that pi of CV plus U is equal to C pi of U, pi of V plus pi of U. Now the next step is we have to show that this mapping is 1, 1 and on. Now we show pi is 1, 1. तो 1, 1 दिखाने के लिए क्या किया जाता है? We have two ways to show whether a mapping is 1, 1 or not. One way is we choose u not equal to v, and this should imply phi of u is not equal to phi of v. This one way. And the second way is we choose phi of u is equal to phi of v, and this should imply u is equal.
V is equal to
यहाँ पे हमें यही थोड़ा सा आसान हो जाएगा, so we will do it. So let
respective on to how.
phi of u is equal to phi of v, और u और v को हमने already define किया हुआ है. Then
सर इसका से 1 1 हाँ कि on to
इस तरह से on to दिखाते हैं, सॉरी 1 1 दिखाते हैं. On to दिखाने के लिए अगर इस तरह से हम on to ऐसे नहीं दिखाते. On to देखिए कैसे दिखाएंगे on to हम. अगर हमारे पास कोई भी फंक्शन होगी f from x into y, then to show on to we will choose y belonging to y, then there exists x belonging to x such that f of x is equal to y. तो इस तरह से दिखाते हैं on to for all. ठीक है, तो इस तरह से दिखाते हैं 1 1. These are two different ways of showing whether a mapping is 1 1 or not. So let two images be equal. Then we know that this is actually something like this. Then that is phi of summation alpha I vi is equal to pi of summation beta I vi, and I is running from 1 to n. This summation is from 1 to n. So then by definition that this gives, now this mapping pi of alpha I vi, this is equal to alpha 1, alpha 2, so on alpha n, and this is equal to beta 1, beta 2, so on beta n. So this is equal if and only if alpha I is equal to beta I for all I running from 1 to n. So once we have alpha is equal to beta I, this implies this alpha 1, sorry, this is alpha 1 v1. This shows alpha 1 v1 plus alpha 2 v2 plus so on plus alpha n vn. This is equal to beta 1 v1, beta 2 v2 plus so on plus beta n vn, because alpha I is equal to beta I. So actually this is the same thing. So this implies what? This implies u is equal to v. So this implies v is equal to u, hence pi is 1 1. So if there we have two equal images, then they must have the same pre-images also. Now the last step is we have to show that pi is owned. So now lastly we show pi is owned. तो इस चीज को करने के लिए हम कोई इमेज चूज करेंगे. सो चूज suppose some pi of v belonging to fn, not phi of v. तो अगर हम fn की रिप्रेजेंटेशन लिखेंगे, हम इस तरह से कोऑर्डिनेट को चूज करेंगे. सो चूज सम a1 a2 so on an belonging to fn, then a1 v1 plus a2 v2 plus so on plus an vn. This element belongs to v because it's a linear combination of basis vectors vi or any vectors from v over the scalars a1 a2 an from the field f. So let x be equal to a1 v1 plus so on plus an vn. तो अगर हम कोई भी n टपल चूज करेंगे fn में से, then we will write this linear combination over the vectors vi's. Then this a1 v1 a2 v2 so on a and vn, this will be an element of v. So therefore there is some x in v which has this representation. So therefore let x is equal to this element. Then what we have, then phi of x will be equal to a1 a2 so on a. So thus phi is on 2. So therefore v is isomorphic to fn. ठीक है. आपको समझ आया ये?
Yes, sir.
Okay, let's take an exercise. Show that P3R is isomorphic to what? R4. तो एक तो हम डायरेक्टली ये थ्योरम ही यूज कर सकते हैं, लेकिन हम इसमें थोड़ा सा देख लेंगे how we will define an isomorphism. So we first have to choose a basis of P3 of R, any basis. Then we will have to define a mapping from P3R into R4, which defines an isomorphism in this way. So let's choose the standard basis.
For that,
Let's choose the standard basis of P3R. ठीक है, which is, suppose beta is equal to 1x x square x cube. ठीक है. Okay, then f of x is equal to a0 plus a1x plus a2x square plus a3x cube. Suppose this is a polynomial in P3 of R. Then we can write this f of x is equal to, we can write this equal to a0 times 1, ये वाला vector. पहला यहाँ पे कोएफिशिएंट a0, then this vector 1, then plus a2 times x, ये वाला vector, then plus a3 times x square plus a4 times, नंबरिंग गलत हो गई यहाँ पे. So this a0, then we have a1, this is a2, this is a3 into x cube. ठीक है. So thus when we define a mapping, thus pi from P3R into R4 is defined as pi of f of x, which is equal to pi of f of x. हमने choose किया था a0 plus a1x plus a2x square plus a3x cube, and now we are defining this is equal to a0 a1 a2 a3. ठीक है. Then this is the mapping which defines an isomorphism. ठीक है. तो समझ आया आपको ये यहाँ पे?
Yes, sir.
ओके चलो पहले हम एक थोड़ी सी डिफरेंट बेस लेंगे जहां पे हमें थोड़ा सा कुछ और करना पड़ेगा नाउ अगेन चूज बीटा इज इक्वल टू हम अब डिफरेंट बेसिस लेंगे suppose we will choose a basis the first element is let's choose it to be 2 then suppose 1 plus x suppose 2 plus x square चलिए 1 plus x square तो कौन सी बेस हमने ली थी 1 plus x क्यूब हम यहाँ पे लेंगे ठीक है now this is also a basis of choose beta equal to this as basis of p3r then choose any polynomial तो अब हम कोई पर्टिकुलर पॉलिनोमियल चूज करेंगे ताकि हमें कैलकुलेशंस करना थोड़ा सा आसान हो जाएगा then we can do the same thing in general also so now let some p of x is equal चलिए अब हम जनरली लेते हैं this a plus b plus cx square plus dx cube be an element of p3 of r ठीक है so once we have p of x belonging to this p3 of r and beta is the basis of P3 of R. Therefore, we can write this P of X as a linear combination of these vectors over some scalars from R. Now, since beta is the basis, beta is the basis of P3R. Thus, we can write, so what we can write? We can write P of X is equal to some अब हमें यहाँ पे कोएफिशिएंट्स चूज करने हैं so it is some alpha 0 times 2 plus alpha 0 क्यों हम लिखेंगे alpha 1 times 2 then alpha 2 times 1 plus x alpha 3 times 2 plus x square plus alpha 4 times 1 plus x plus ये ठीक है ये स्टेप यहाँ पे we are given this beta is a base of p3 of r और अब हमने p3 of r से एक एलिमेंट चूज किया p of x which is defined in this way now a b c d are some fixed constants from there are some real numbers तो ये अब यहाँ पे फिक्स्ड है
X cube. It's X cube here.
so once we have chosen any vector from p3 of r we can write that vector as a linear combination of these vectors with some scalars from the set of real numbers तो यहाँ पे अब हमने वो scalars choose की alpha 1 alpha 2 alpha 3 and alpha 4 so therefore we can write this p of x as alpha 1 times 2 alpha 2 times 1 plus x alpha 3 times 2 plus x square and alpha 4 times 1 plus x cube तो अब हम देखेंगे now using this we will try to find out what is the exact value of this alpha 1 in terms of some fixed real numbers तो वो obviously हमें यहाँ पे आंसर आ जाएगा in terms of a b c d चलो ठीक है हम यहाँ पे एक यहाँ पे हटा देते हैं हम यहाँ पे d की जगह पे सम लेट्स राइट 5 हम कुछ भी लिख सकते हैं ठीक है ओके सो दिस गिव्स चलो ये हम नेक्स्ट पेज पे लिखते हैं दिस गिव्स a plus bx plus cx square plus 5x cube this is equal to 2 alpha 1 plus then what was the next one उसके बाद क्या था alpha 2 times 1 plus x
Alpha 2 plus 1 plus x.
alpha 2 times 1 plus x then alpha 3 times 2 plus x square, then alpha 4 times 1 plus x cube. Now let's simplify the right hand side. तो यहाँ पे जो constants है alpha 1, so here we have the, हम यहाँ पे लिखेंगे पहले 2 alpha 1, then here we have alpha 2, then here we have 2 alpha 3, and then here we have alpha 4. So these are all constants because alpha 1, alpha 2, alpha 3, alpha 4, they are also real numbers. Then next, the coefficients of x. It is alpha 2, then plus alpha 4 times x. Then coefficients of x square. चलो ये हम शायद यहाँ पे लिख पाएंगे. It is alpha 3 x square, ठीक है. Then coefficients of x cube. Then it's alpha 4 x cube. So now comparing the coefficients. Comparing the coefficients we get. तो हमें यहाँ से क्या मिलेगा? हमें यहाँ पे डायरेक्टली मिल जाएगा alpha 4 is equal to 5. We get alpha 4 is equal to 5, ठीक है. और इसी तरह से alpha 3 is equal to c. Then we have alpha 2 plus alpha 4. This is equal to b. और इसी के बाद 2 alpha 1 plus alpha 2 plus alpha 2 plus 2 alpha 3, but alpha 3 is equal to c, so it is 2c plus alpha 4 is equal to 5. And what is this equal to?
A.
ठीक है. तो ये दो तो हमें मिल गई. अब हमें इन दो इक्वेशन से ये अल्फा 1, अल्फा 2 और अल्फा 4 निकालना है. ये क्या होगा इसको? यहाँ पे अल्फा 4 है ये. ओके ठीक है. लेकिन यहाँ तो हमें डायरेक्टली मिल जाएगा ना. अल्फा 4 का वैल्यू हम यहाँ पे लिख सकते हैं. दिस अल्फा 4 is equal to 5. So therefore this implies alpha 2 is equal to b minus 5. तो अल्फा 2 भी हमें मिल गया. And then alpha 1, this is equal to a minus 2c,
minus 5.
then minus 2 alpha 1. हमें कौन सा निकला? अल्फा minus b plus 5. चलिए
minus
b plus
इतना ही है यहाँ पे. So I think this a minus 2c minus b
divided by
divided by 2.
divided by 2. So thus जो हमारे पास p of x था, thus p of x, it was equal to alpha 1 times 2. अब alpha 1 की जगह पे हमारे पास ये है. It is a minus 2c minus b
minus 2
divided by 2 times 2. Then plus alpha 2 times 1 plus x. So it's alpha 2, लेकिन है यहाँ पे हमारे पास b minus 5 times 1 plus x. Then alpha 3 times. So it is c times 2 plus x square. Then 5 times 1 plus x cube.
plus x.
So therefore, we have represented this p of x as a linear combination of vectors 2, 1 plus x, 2 plus x square, 1 plus x square with some scalars from the set of real numbers. और एक scalar ये है हमारे पास, दूसरा है b minus 5, then we have c, then we have 5. तो जो अब हम mapping define करेंगे. So thus जो हम mapping वहाँ पे define करते थे 5, तो अब under now this p of x has its image as what? A minus B minus 2C divided by 2 is the first coordinate. Second coordinate is B minus 5. Third coordinate is C. And the fourth coordinate is 5. And in R4. ठीक है, तो इस तरह से हम किसी भी, अगर हमारे पास कोई भी ये P of X होगा, तो हम उसका जो mapping होगी that we can define in this way. So then this mapping will define an isomorphism. Now we have just less than a minute left, so I think we should join for the next meeting.